Oh my god, people, I just made a video and didn't record the sound. Shoot, man. I didn't record the sound. Dang. I gotta do this all over. It was like a 9-minute video. Oh, gosh, this just breaks my heart. So, dang. Oh, man, I'm tired as it is. 6 o'clock, too. Okay, so cotangent, this looks like a lot, but cotangent is shaped like this, and then looks like we go to the right, pi, but cotangent has a period of pi, and you'll notice that it's not a b, so therefore you are just going to go from 0 to pi, okay, because that's what cotangent does. He goes, now tangent does this, okay, but cotangent goes here. He's just a little shift. All right, and because he shifted over pi, that means that this guy is going to look the same. There's like no shift graphically, okay? Technically, algebraically, yes, but graphically, no shift. So cotangent is this shape. We're going to go up 3, so we move the whole thing 3. We are going to, when we move over 1, we'll go up a half, but let's make sure that we've got, yeah, there's no other shifts here, so that should be good, okay? It's a little quicker than what I actually explained it in my last video. Kind of, it sucks so bad. Anyways, here's cosine. Great, but the problem with this guy is that you do have b. In fact, it's not actually a problem, though. When this b value is on the outside of parentheses, you do not have to do this formula, okay? If that 2 over 3 would have been in the parentheses, then you would have had to have done this formula. It's an unfortunate situation with trigonometric functions. Some resources will have it out, which is better. Some resources will have it in. I believe the software that I have will put this guy in. And so therefore you have to do this in order to get the actual phase shift. So watch out for that. I taught that for the, oh my gosh. I taught it for like 3 days the wrong way my first year teaching trigonometry to a pre-calc class, and it was just a disaster. And I think I lied about it too once I realized it. I like almost had a heart attack, and then I just lied about it for the rest of the year. It was at the end of the year anyway, but yeah, it was just horrible. Don't tell them that I did that, but they there might be 10 people out there who have no idea what's going on with this. Anyways, 5 over 2 is the amplitude. Now, he does have an amplitude because he's cosine. Only cosine and sine have an amplitude. So we do have 2 over 3 here. That is the b. So in order to find the period, you get 3 pi. If I start here and then do my phase shift, you'll notice that if I started at 0, I actually will go off my graph because 3 pi is like over here. So what you can do is just do the phase shift this way. Now, if I go to the left, phase shift is to the left 3 pi over 4, okay? 3 pi over 4 is 3 pi over 4s. So each one of these units is a pi over 4. So I went over 1, 2, 3. Now if I do that, that allows me to have room to actually do a full 3 pi period. So let's just make sure that we've got that. Pi is 4, so if I have 3 pi, that's a number, that's 12 units. So let's make sure that that's the case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, full period. So there it is, top to top, because it's cosine. Remember, he looks like this. God, I can't believe I didn't hit record. Oh, that's so frustrating. Seriously, it was a 10-minute, and I cracked so many jokes. Like, you have no idea. You guys totally robbed of my humor now because I did not hit record. Now all my jokes are just going to fall flat. Okay, so we went down 1, and then from here, yeah, okay, so hopefully that makes sense. You can flag me down if you have any questions here. You can see I marked all this up, man. I was on a roll. And there was like a joke here, there was a joke there. I had a really good story here, and it's all gone, forever gone. So here, this you use a unit circle. You want to find out where is arc sine radical 2 over 2. Now, you need one answer. Remember, arc sine happens in these two quadrants. So you are not going to go to this radical 2 over 2. You're going to go to this one, and that is at pi over 4. Arctangent, if he's negative, okay? If he is negative and you end up at, let's see, where is he negative? If he went this way, negative radical 3, that happens at a pi over 3 family, because sine would have to be radical 3. So that would take us right up here, but he's got to be negative, so he's got to be down here. And that distance is a pi over 3. Okay. Here, arc cosine. You can only have the angle that comes out equal to either the first or the second quadrant. So negative radical 3 over 2 has to happen here. Okay? Has to happen there. Oh, you know why I wrote this? Because this is what it would be if it was wrong. Okay? That's it would be if it was wrong. Okay. So this guy is going to be 5 pi over 6. Okay, this guy is exactly as he is because the arc cosine is inside the regular sine. Arc tangent inside the regular tangent. Arc sine inside the regular sine. Cool, right? No, this guy's bigger than 1, so that's why he's a DNE. Okay, so make sure that that theta or the arc sine has to be less than 1. All right, tangent, negative pi over 6. Cool, that is within the first and fourth quadrants, so that is good. You can just spit that out. This guy over here, he is good because 2 pi over 3 is in the 2 quadrants that cosine is good. So there, or arc cosine is good, so that's good. This guy is not. Negative 3 pi over 2 actually goes all the way over here. That is pi over 2. Okay, if we have to put it in the first and fourth quadrants, we have to in order to get an arc sine. So whenever you have the arc tangent or arc function inside the regular function, it is what it is, unless it's over 1. But over here, if you've got the regular function inside here, you have to differentiate and make sure that you modify this so it fits in the right quadrants, okay, the correct quadrants. So this guy really is a pi over 2, okay. This guy, 11 pi over 6, is actually here, okay, going all the way over here. So cosine is going to be positive over there. So what's going to come out of an arc cosine is going to be the positive version of that reference angle. If it was negative, it would actually be over here. It would have been 5 pi over 6. Okay. This guy's 4 pi over 3. He's in the wrong location. 4 pi over 3 would take us all the way over here. Here, that is a negative sign, but we need to put it in this quadrant, so he will just be recognized as negative pi over 3. Okay. This guy, negative 5 pi over 4, takes us over here. That is negative tangent. Where is tangent supposed to be? Here and here. Here if he's positive, here if he's negative. But because he's negative, he will go exactly here. That is a negative pi over 4. Okay, is that it? That is it. Now, I did it, actually. And I'm sorry. I'm super sorry you missed all those jokes, man. They were so good. But romantically, or rather kind of sad, I mean, this is seniors. This is the last videos you're going to see of me making study guide videos. This it's a very sad moment for you, I'm sure. If you are still listening to me and you put a star next to your name, you're gonna get extra credit +3 on your test just to hang in there. And I hope that all is well. And I will see you tomorrow. I hope that helps.